Hello, thank you for your interest in my presentation. My name is Joe Wigglesworth, and I'm a product architect. I work out of the IBM laboratory in Toronto, Canada. And what I'd like to talk about in my presentation today is some work that we've been doing to build upon OpenStack Heat. So just to give a little bit of background, though most of you are probably aware, the Heat project is the project within OpenStack that provides orchestration capabilities. And this is the tool that you would use if you want to define how your OpenStack resources would be created, then deployed, modified, and eventually deleted. And so the project itself is very useful, but honestly, it's when you combine it with other technologies that I think Heat really reaches its true potential. So what we've done, and what I'll talk about, is how we've combined that with other open technologies to create something more than just an orchestration template, but something that we're calling an open pattern. And then to make this real, I'll also describe what we've developed called the Open Pattern Engine. And that project combines the Heat engine along with other open technologies to deploy these patterns. And the result is that we get an environment that deploys the open patterns and makes Heat very effective. So let's take a look at what an open pattern would include. So of course, when you're putting together a deployment, the basic building blocks of any deployment are the operating system images. So these are considered to be part of the pattern. And of course, some of the most common ones are Ubuntu and Red Hat, SUSE, but honestly, any operating system that you're needing to deploy is certainly can be part of the pattern. Now, on top of that is where we put the software. So that could come in a lot of different forms. Of course, containers are hot, so installing containers on top of an operating system where you have Docker installed, for example, is one thing. Or it can be traditional packages that you can get from something like Yum, or even simpler, just zip files or tarballs or whatever it is but they are also now part of the pattern as well. And the next piece would be the configuration management scripts. So putting this together, we now run scripts that will modify both the software that's been installed and make any modifications that you need to the operating system. And some common configuration management tools that you'll see today, certainly not limited to this, but Chef, Ansible, Salt, and Puppet. So now we're slowly building it up, and the last layer is the orchestration layer. And this is the part of the open pattern that basically controls the end-to-end flow of putting all these things together. And that's the role where OpenStack Heat comes in. So Heat now, when we talk about the resources that we need, it will define the virtual machines, can work, of course, with containers. It can also create the software and call the scripts that are needed to put the whole pattern together. And so the result you have when you put all these pieces together is more than just a template. It's what we call an open pattern. So graphically what that could look like, and it's an open pattern because there is a lot of choice. If you think of an open pattern as a bit of a layer cake, on the bottom are our operating systems where we can have a lot of choice there. I mentioned those already. Software installation on top of the operating system is where we can have our containers, Docker, Rocket, or anything that meets the Open Container Initiative. Can be traditional patterns. And then the configuration management piece, Salt, Chef, Ansible, Puppet, or whatever you're working with that will provide that configuration management and ongoing desired state management. And then on top, the orchestration scripting. And here that could be things like, we focus on Heat, but others include CloudFormation, Terraform, or Docker Compose, even if you're doing most of your work with containers. So that's the pattern, and that's the definition of what you're going to deploy with all those pieces. But of course, you need an environment to do this in. And that's where the engine comes in, what we're called the open pattern engine. And we combine that with the heat engine that we have today. And what we want to do is put together something that pulls together all the pieces that you need to have a useful environment. So you need the configuration management tool, and so that would be like a server, like a chef server or a salt server. You need that in your environment. You need a template editor. Now, of course, a lot of people just use text editors for editing things like a heat template, but we've actually used something, like I mentioned, I work at IBM, and we have a product called Urban Code Deploy, which has a heat editor that understands the syntax of heat, and also it allows you to graphically edit heat templates. So that's part of our engine. A source code repository with version control is very important. So what we do in our engine is we bundle in Git. You don't even see it, it's just there. All the text files go into Git. That's your heat templates, your chef recipes, salt formulas, whatever it is you're working with. The software needs to go somewhere, so we set up just an HTTP server, but that binary media library could be your own Docker repository, private registry, or wherever you're getting your binary from. And then the last piece, which is a bit unique here, is we've created also a framework for management operations, because it's fine to just deploy these patterns, but what you want to do is go beyond that and keep it running. We talk a lot about day 2 operations, the things that happen after it's been deployed. So we're working on a project that internally we're just calling Xeron for now, but it's there to help with hooking in things like monitoring, patch management, and also log retrieval, and let's see what other pieces. Those are the main ones as well. It also allows you to run operations on your endpoints. So what that would look like here, and the graphic shows it on the right, is we have open patterns, as I've defined at the beginning, that feed into the open pattern engine, the gold bar in the middle, with the different pieces. The orchestration, which for our purposes in our initial run at this is we're using heat for that. The configuration management, which is Chef, providing the automation. Version control, from Git. The text editor, which can also be a graphical designer. Now, like I said, this one's a bit on the optional side, but if you've got one, it's a big help to have the text editor there. And it can help you to pull together your patterns and then allow you to deploy them in a very effective way. And then the lifecycle management, and that's that Xeron piece that we're working on. So we're still thinking about whether or not that's a project that we want to add to OpenStack. We think it's very useful, and it's a kind of an overlooked piece when it comes to deployments of patterns. And this is the piece I mentioned earlier that does things like license tracking, so it'll tell you what you're using in your different virtual machines, log management and retrieval for doing troubleshooting, monitoring your operating system and any middleware that you have, and doing updates. So that could be operating system updates. It could be updates to your middleware or your end applications. And all of that is built upon and can be deployed to different kinds of clouds. So it could be a cloud that you just have local within your own data center, local cloud, or a dedicated cloud, which is one that you've provisioned and paid for that is out off the premise in someone else's data center, but it is just for you, a dedicated cloud. Or it could be a shared cloud, something like Amazon or SoftLayer or things like that, where you are just one of many people who's using the cloud. So the engine is there to deploy the patterns, and these are the pieces that put that together. So what that looks like at a really high level is the large box here that's taking up most of the screen is with the engine services. So that's the Git repositories are there, the graphical editor is there, your media library, and the configuration management server, which is things like, that would be Chef or Puppet or Salt. So the user interface interacts with that. You can import a pattern into this engine and then edit it. And when that's been done, then you can then basically call the OpenStack heat engine to deploy it, which will then go through the normal process of deploying it onto the compute and the guest virtual machines where the configuration agents are there and the endpoint management. So to wrap up, the Open Pattern Engine is for deploying open patterns. The open patterns are a combination of technologies that are built upon the power of heat, and the Open Pattern Engine provides the environment for creating, deploying, and managing these open patterns. And the result of these open patterns and the engine to deploy them is a supercharged combination for defining and creating software systems in a reproducible, error-free way, and of course, one that's very portable. Thank you very much.